Okay, this is just using a new statistical approximation. So now our original distribution is a Poisson one, and we're going to be using a distributional approximation. And the only approximation we can do to a Poisson is a normal, and for that we need lambda to be large, and 25 is large enough. So the normal steps are, you set up the exact distribution that you're dealing with, you think about what approximation you're going to need, and you set up the parameters for that approximation before you write down the approximation. So here the exact one given in the question is the Poisson with the mean of 25, but it's always a good idea to write lambda equals 25. Now the parameters I need, well, the approximation I'm going to do is a Poisson. The only approximation I know is going to be a normal approximation, but I need to set up the parameters for that. So what do I need? Well, I need a mu, and a mu for a Poisson distribution is just the value of lambda, so that's going to be 25, that's the mean. And the other thing I can easily get is that the variance of a Poisson is also lambda, but the variance is not sigma, it's sigma squared. So sigma squared is lambda, which is 25 too. So the numbers in my normal, mean is 25, variance is 25, but of course it's not the variance that we're actually going to be using. So it's always a good idea to write mu equals 25 and sigma equals, which is the square root of 25, which in this case is 5. And of course sigma squared is 25. So if you always set up your sigma and your sigma squared, you're unlikely to go wrong with your probabilities. So what I've done here is I've done part A. Essentially I've set up the distribution that we can use as an approximation. And in part B I've got some probabilities. Now once again, as with binomial, Poisson is discrete and normal is continuous, so we need continuity corrections. Probability of x being less than 16. The original numbers in this question were silly, so I've had to change them. Okay, if they're not changed in your booklet, then we'll have to change them in class. So, probability of x being less than 16, well, I do my number line with my outcomes, and I put my ticks and crosses on, like so. I'm less than 16, so I can have 15, but I can't have 16. So this shows me that the cutoff value for my continuity correction is at 15.5. So the corrected probability that I need is to work out the probability that x is less than 15.5, that cutoff point. Okay, and now we're ready to work out this probability using our normal approximation. So as always we need a sketch, and the mean of the distribution is 25. 15.5 is not stupidly far away from that, so the diagram looks like this. We want to be less than 15.5, so I need the z for 15.5, so z equals 15.5 minus 25 divided by sigma, not sigma squared, so I'm dividing by 5, not by 25, so 5 on the bottom, and my calculator gives me that z is minus 1.9. So I've got a z value of minus 1.9. My diagram shows that I need to use that as the upper, and the lower is minus 9999, like so. Press equals, and we get our probability, our p equals 0.2872 to 4 significant figures. Okay, so this, if you've done binomial approximation by a normal distribution, then Poisson is just the only step that's different is how we set up the normal distribution, which is very easy. We set both mu and sigma squared equal to lambda, and we don't forget to square root our sigma squared. We've done that for this question, so we just got to do 3 more continuity corrections and the normal probabilities. So for the next probability, the next continuity correction, part 2, we want values near 18. 17, 19. This time I am allowed to equal 18, and anything less I'm not allowed to equal 19, so my box would be like that, but my continuity correction uses the cutoff value 18.5, so I want the probability of x being less than 18.5, so it's just as before, except this 15.5 in the sketch has become an 18.5, still got 25 in the middle. Still working out the probability of being less than, so my z is now 18.5 minus 25 over 5, which is minus 1.3. Okay, and then when I use that as my upper bound on my calculator, minus 1.3, lower is still minus 9999, I get a probability of 0.09680. Okay, for the next one, we've got the probability of x being greater than 30. So values near 30, 0, 29, 30, 31, ... Okay, I want to be greater than 30, so I'm not allowed to equal 30. I am allowed to equal 31. I'm not allowed to equal any of these. So my boxes would be, I'd have a box around the whole lot, and I'd have a box up to 30 to get rid of those. So my cutoff point is between 30 and 31. So I want the probability of x being greater than 30.5. So my diagram will still have 25 in the middle, but now I want 30.5, and I want to be greater than that. Oops, so there's my diagram. I want to be greater than 30.5, so we need a z value, which is going to be our 30.5 minus our 25 divided by 5, which is 1.1, and so I use that now as the lower, and as my upper I have 9999, so my z value is 1.1, my upper is 9999, and I get a probability of 0.1357. P equals 0.1357. 7. Yeah. To 4 significant figures. And just one more to do, so I've got one more continuity correction essentially to do, which is 14 is less than or equal to x is less than 17. So the diagram would be 0, ... 13, 14, 15, 16, 17, 18. So what am I allowed? I'm not allowed 13, not allowed 0. I am allowed 14 or 15 or 16, but I'm less than 17, so I can't have these. So my two boxes, I'd have a box between 16 and 17, and I'd have a box between 13 and 14. So I want the probability of 13.5 being less than x, being less than or equal to, or being less than 16.5. Okay, I could put less than or equal to, it wouldn't be wrong, because the probability on a normal of being exactly 16.5 is 0. So I need to convert these two things to z's. I'm doing this very lazily. I've run out of space on this bit of paper underneath. So I'm just going to show you the z's. They're minus 2.3 and minus 1.7. So on your calculator, with minus 2.3 and minus 1.7, we get this probability here. So I'm just going to simply record that as my answer to 4. So that is P equals 0.03384. Now, in your notes, I'd like this all to be written up properly like we did the others, okay? But that's just showing you the answer. For C, we've got to justify the use of a distributional approximation. So we've already thought about that when we set up the distributional approximation. Why am I allowed to set up a normal distribution? Because of the original distribution, my lambda, which was 25, was large. So that's all we have to write for part C. So down at the bottom of the question, so C lambda equals 25, which is large, and that justifies the approximation.